Hello guys, my name is Bob. Today in this video I'm going to solve the integration of x cubed plus 1 over x to the power 4 plus x to the power 3 plus x squared plus x dx. The first thing we do is we factorize the numerator and the denominator. So for the numerator we factorize x plus 1 out, and then the other factor is x squared minus x plus 1. Okay, you can work this numerator out. It will give you back x cubed plus 1 over the denominator. The denominator is more obvious. You can just factorize the x out. It becomes x bracket x cubed plus x squared plus x plus 1 dx. Okay, the next step we do is we multiply, right, x minus 1 on both the numerator and the denominator of the fraction. Right, so what we have here is integration of x plus 1 x squared minus x plus 1 x minus 1 over x bracket x cubed plus x squared plus x plus 1 x minus 1. So from here we combine, okay, or multiply the factor x plus 1 with x minus 1, so we get x squared minus 1 x squared minus x plus 1 over x, and in the bottom, which is the denominator, you can multiply the factor x cubed plus x squared plus x plus 1 with x minus 1, so you get x to the power 4 minus 1. Okay, you can work this out. Okay, the next thing we do is we further split this x to the power 4 minus 1 into x squared minus 1 and x squared plus 1. Okay, we keep the numerator as it is. Why do we do the split? Is because in the next step after this, okay, we will do something. All right, so that something is quite straightforward. We just have to cancel, okay, the x squared minus 1 on top with the bottom, because when you divide x squared minus 1 on top with the bottom, it just gives you 1. Then now you have x squared minus x plus 1 over x bracket x squared plus 1. So amazing. Yeah, so this, okay, what you can do is complete the squares in the numerator. So how do we go about completing the squares in the numerator? First thing you need to understand is about how the completing the squares in the numerator is done. It won't be shown here, but I will show you the answer to what is after completing the squares for the numerator. So on the top itself, it is x minus 1 square plus x over x bracket x squared plus 1 dx. And then we split this fraction up into two fractions. So the first fraction will be x minus 1 squared over x bracket x squared plus 1 dx plus integration of x over x bracket x squared plus 1 dx. Okay, let's look at the second term. All right, the second term we can cancel, okay, the x's, so we will leave the second term as it is. It will have 1 over the x squared plus 1 dx. So for the first term, we further split out, the first term. Actually, we expand the first term into x squared minus 2x plus 1 over x bracket x squared plus 1 dx. Okay, and then the next step from here, the first term will be further split out into two fractions. So we got the integral of x squared plus 1 over x bracket x squared plus 1 minus away 2x over x bracket x squared plus 1. Right, so we can do this as a bracket plus integral of 1 over x squared plus 1 dx. Okay, so we now have this equation. We can cancel the numerator with the denominator. Okay, and then we end up with the integration of 1 over x dx. Subtracting it away, the next term, we cancel the x from the top and the bottom. We have the integration of 2 over x squared plus 1 dx plus integration of 1 over x squared plus 1 dx. So this, the second and third term can be combined. So this is equivalent to integration of 1 over x dx minus integration of 1 over x squared plus 1 dx. We know the integration of 1 over x dx is just basically ln x, while the integration of 1 over x squared plus 1 dx is tangent inverse x, and we have the absolute for the x itself, so and plus c. Okay, and that is the final answer to the question, the integration of x cubed plus 1 over x to the power 4 plus x cubed plus x squared plus x. Right? It involves a lot of splitting out the fraction into two so that it can make the fraction more simplified in such a way that you'll be able to eventually integrate and get the final answer. That's about it from me. Thank you guys for watching, and I will see you in the next video.